Okay, the last thing we're going to talk about in Unit 3 is geometric transformations. We're going to go specifically into translations, rotations, and reflections. And, the thing that's kind of tough about teaching this class is, if we were teaching this in, a K through 12 classroom, we would spend an entire unit on these transformations. And I have one lesson to spend with you because we do have to cover a lot of math in a short amount of time. But I do want to talk to you about these transformations, show you some examples. Hopefully this is all review for you. But this is a really fun thing to teach. You can do a lot of really cool activities with this, and you can even expand that out and do some different types of projects with these and have a lot of fun with it. Also in this, if I were teaching this in a K through 12 classroom, I would also go into dilations. That's not something we're going to talk about in this lesson. We're only going to focus on translations, rotations, and reflections. But we would, in a K through 12 classroom, go into dilations. What I want to do is I want to go to Lead Forward, and what I have here is the 8th grade standards. And I just pulled up the geometry and measurement section here, and I want you to notice here, at 8.10c, explain the effect of translations, reflections over the x or y axis, and rotations limited to 90, 180, 270, and 360 degrees is applied to two-dimensional shapes. And that's basically the gist of what we're going to do in this lesson. We're going to focus on translations, reflections, and rotations, and we are going to limit the rotations to these increment of 90-degree rotations: 90, 180, 270, and 360. You can come over here also and look at the standards that support that. And just see, we're going to talk in these standards more about rotations, reflections, translations, and you do see dilations here. That's not something we are going to cover in this lesson, just because we don't have the time to go into that. We did cover similar figures, and we have talked some about some scale factors, but we're not going to go into dilations, although you would in an 8th grade classroom in the state of Texas. And so, you would model the effect on linear and area measurements of dilated two-dimensional shapes. So that is something that you would go into if you were teaching this in the 8th grade in Texas. So we'll look at some activities for these things, but first I just want to go into some basic definitions and start with some simple examples. So the first transformation we're going to talk about is a translation. A translation is the motion of a plane that moves every point of the plane a specified distance in a specified direction along a straight line. So we refer to this also as a slide, where you are going to take whatever figure you are given on the plane and you are going to slide it to a new position. Wherever this figure lands, it will be congruent to the original figure that you start with. It's going to be the exact same shape and the exact same size in a different position on the plane. Properties of translation: the figure and its image are congruent. The figure is what you start with. The image is where the figure lands, the ending product, but they are congruent to each other. The image of the line is a line parallel to it. So if we start with a line and we translate it, we slide it to a new position, wherever it lands, it's not changing the steepness or the slope of the line, so it will be parallel to the line that you started with. The image of the figure under the translation can be constructed with tracing paper, or using a compass and a straight edge, or using a geoboard or grid, which is dot paper. So we're going to do some translations on dot paper on the first example, and then we're going to move into some translations on a coordinate plane, and we'll do a couple of those. So there are multiple ways that you can do these. Like it says, you can use a compass and a straight edge, tracing paper, but we're going to stick to doing it on dot paper, and then we're going to go into doing some of them on a coordinate plane. Now, one thing that's very important that you understand is that the original image is P. That's the pre-image before it's translated. And after it's translated, that is what we refer to as P prime, this little Sorry, I had a little hiccup with my computer. This little apostrophe looking thing here is considered prime. And so P prime is the image after it has been transformed. So on the dot paper, and you can also use a geoboard if you have that in your classroom with rubber bands. That can be fun for students at times. But this here, this arrow shows the direction in which we will translate it. Whereas when we get to a coordinate plane, it's more about shifting left and right as far as, the x-axis is horizontal, the y-axis is vertical. And so it will be, the transformation will be described in a different way than if we are on dot paper. So this arrow describes the direction in which the shape needs to be translated. And so what you're going to do is you're going to use this arrow as your guide. And I always just, before I ever start or worry about anything, I think, okay, how would I get from this point to this point? Because that is the direction in which it's telling me to take this W figure here and slide it. So to get this, we always count vertically and horizontally. So I need to take every point and I need to go 2 down, 2 dots down, and then 1, 2, 3 dots to the right. So 2 down and 3 to the right. And that's what I'm going to do with every point on the W figure. And I'm going to use this point, this point, this point, this point, and this point as a guide to do that. So all of those points, all 5 of those points, I'm going to shift them 2 down and 3 to the right. And translations are very easy. It's simply a matter of counting left and right and up and down. So if I take this first point here and I go 1, 2 down and 1, 2, 3 to the right, that is where that top left corner point will land. Here, same thing, I'm going to go 2 down and 1, 2, 3 to the right. Here I'll take this, go 1, 2 down, 1, 2, 3 to the right. Okay, at this point, 1, 2 down, 1, 2, 3 to the right. And then the last point, 1, 2 down, 1, 2, 3 to the right. And then I'm going to connect those in the same way they are connected on the original. And there is my translated image. So translate means to slide. We have basically taken this W-shaped figure and we have slid it 2 down and 3 to the right as the arrow indicated. This is P, the pre-image. This is P prime, the image after it was translated. And so this here would be our answer. And that's how we do it if we're doing it on dot paper. Now the next example, we're going to go to a coordinate plane. And we're going to do 2 more examples in this video to cover translations more. A translation is a function from a plane to a plane such that every point xy corresponds to the point x plus a, which is going to indicate how you're moving horizontally, and y plus b, indicating how you're moving vertically. Keep in mind that a and b can be negative numbers. So if it is negative, negative would be going to the left on the x-axis. A negative with the y would be indicate shifting down. A positive with the a with the x is going to be indicating going to the right, to the positive x direction, and a positive b value would indicate that you're moving upward on the y-axis. So on this particular problem, we're going to take this shape, this figure, and we're going to find the coordinates of the image meaning after it has been translated under the translation that's given and described here. So when we look at this here is our original. This is our pre-image. And this is basically our rules for how we're going to slide it. Now when it says x minus 2, that's taking x and going to the left 2 to the negative direction 2. And so what this means is we're going to take this shape and we're going to go to the left 2. Y plus 4 says take the y and go up 4 because the y-axis runs vertically. And so we're going to go up 4. So keep in mind that your x-axis runs horizontally, your y-axis runs vertically. So anything with the x is going to give you your left or right shift. Anything with your y is going to give you your up or down shift. So positive on the y means up, minus on the y means down, minus on the x means left, positive on the x means right. So we're going to take this shape and we're going to find the coordinates, which means it wants the xy coordinates of the image. And so when we do that, what I'm going to do here, and I think it'll just help us maybe just do this a little bit more detailed, but I want to show you some numerical relationships. So what I'm going to do is I'm going to put points on all of those vertices, and I'm going to label them with, let's start here, and let's go A, B, C, D here, E here, and F here. And we're going to take those vertices and we're going to shift all of them to the left 2 and up 4. But before we do that, I want to write down the coordinates of these points. And that'll kind of also just help us with our coordinates. So when I'm looking here, A is located at 1, 2 as far as its xy coordinate. B is at 1, 5. C would be at 2, 5. D is going to be at 2, 4. E is at 3, 4. And then F is going to be at 3, 2. So these are all points of the pre-image. And then I'm going to switch to a different color to find my image. So let's take every one of these points, all 6 of these points, and go left 2 up 4. So I'm going to start with A. I'm going to go left 2 up 1, 2, 3, 4, and that is A prime. B, I'm going to again go left 2 up 1, 2, 3, 4, and that's going to be B prime. C, we're going left 2 up 1, 2, 3, 4, giving me C prime. D, left 2, 1, 2, 3, 4, that's going to be D prime. E, left 2, 1, 2, 3, 4, giving me right there E prime. And then F, 2 back, left 2 up 1, 2, 3, 4, and that's going to be F prime. And then you will connect this in the same manner that the vertices are connected on the pre-image, on the original. And you'll notice you get a shape that is congruent to the original. And that happened on the last example as well. Like this W, if drawn correctly, should be congruent to the original. Here, this pink figure is congruent to the original. And so I want you to take note that this is the image after it's been translated, and the original is the pre-image. What we're going to do now is we're going to write down the coordinates of the image. And so here, A prime, if I'm looking at it, this is at -1, 6. B is at -1, 9. C is at 0, 9. D, if we look at where D prime is located, I mean, you can count those coordinates if you need to, but that's going to be at 0, 8. E, if we look at that, that's going to be at 1, 8. And then F prime is at 1, 6. And what I want you to recognize in comparing these coordinates is that every one of these x coordinates is if you take this original x coordinate and if you subtract 2. So 1 minus 2 is -1. 1 minus 2 is -1. 2 minus 2 is 0. 2 minus 2 is 0. 3 minus 2 is 1. 3 minus 2 is 1. On the y's, it's all of the original y coordinates, but adding 4 because it shifted up 4. So 2 plus 4 is 6. 5 plus 4 is 9. Down here on the 4 plus 4 is 8. 2 plus 4 is 6. So here, these are the original coordinates of the pre-image, and then finally we have the coordinates of the image, which is what the problem asked for. Okay, one final example in this video. We want to find the coordinates of the points whose image under the translation are xy was translated to x plus 2, y plus 4, and we have the following image points. Notice you are given the image points A prime, B prime, C prime, and we want to find the original because it's telling you you have the image. You are given the image, which is different than what the last problem told you. And this is going to be on your homework. This is going to be on the exam. This is a highly missed problem. So I want you to like put a little star here and make sure you come back and study this one. But it says find the coordinates of the point whose image is this. This problem says find the coordinates of the image. Like we don't know the image, where on this one it's telling you this is the image. Go backwards and find the pre-image. And so A prime is here at 0, 0. B prime is at -2, 3. And C prime is at -1, 2, 3, 4, -5, -3. We count that again. 1, 2, 3, 4, 5, -3. That is where C prime is located. And I'm going ahead and going to connect these into a triangle. But here is the image. Now this is how this was translated. This is how this was shifted. And so since we're going backwards to find the original, because it says this is the image, we're finding the pre-image, what I need to do is I need to go backwards from what this rule said. This says, you know, the original was taken to the right 2 and down 4, because +2 means go to the right 2, -4 means go down 4. So what I need to do in order to reverse that is I need to take these 3 points and I need to go to the left 2 and I need to go up 4 to go back and find the original shape. So I'm going to take A prime, I'm going to go left 2 and then up 1, 2, 3, 4, and that is A, the pre-image of A prime. B, same thing. I'm going to go left 2, up 1, 2, 3, 4, and this is the pre-image of B. C, I'm going to go left 2, up 1, 2, 3, 4, and that's going to be the original C. Okay, so if we connect those, we would have the pre-image of this triangle, triangle ABC. The bottom part here says connect A prime, B prime, and C prime, which we've already done, to form a triangle, and points A, B, and C to form a second triangle. What is the relationship between them? And one of the properties that we've already talked about is that when you do a translation, you end up with a figure that is congruent to the original. And so to write that statement correctly, we would say triangle ABC is congruent to triangle A prime, B prime, C prime.